W.C. Fields famously said that he never drank water because fish live in it, like my buddy Bart here. Well, he's right about that. But fish aren't the only things in the water. Water is a great transportation system, and lots of things make their way to and through our water bodies. The key is to make sure that those things don't get into our bodies. In the United States, our water is so clean that WC can take a long draw out of the nearest tap and know it's clean and safe, no matter where he's at. That brings up a good point. What exactly is in our water? Where does it come from? And what do we do about it? One of the main culprits is heavy metal. No, not that kind of heavy metal. We usually think of heavy metal pollution as happening in industrial areas. You know, factories, plants, and mines. But cars are a significant source of heavy metal pollution. They are little pollution-making factories. Brakes release copper, tire wear releases zinc, and oil takes on metal as it moves through the engine and then leaks out onto the road. These metals attach themselves to the road surface and then are washed into storm drains and waterways by rain. Iron gets into our water from rusting cars and engine parts. My clunker's in here somewhere. That's just the beginning. Phosphorus and nitrogen, you know, the stuff that makes crops grow and landscaping lush, they are nutrients. And as it turns out, you can have too much of a good thing. When we overdo the nutrients, the next rainfall carries them into the storm drain and nearby water bodies. There, they encourage the water plants to overgrow. When that happens, the plants use up all the oxygen. It gives fish and other living things a bad attitude. I bet you'd be unhappy if we used up all the oxygen in the room you're in and there was none left for you. Fish and other things that live in the water feel the same way. And as much as we love our lawns and food on our tables, it takes more than nutrients. It takes a little pesticide, too. And pesticides are poison. Because water is such a great transportation system, pesticides follow the nutrients into the water systems. Yum. Well, heck, we've met the polluters and it's us. Or the people who feed us or keep our iPods charged. But that's not all. There's stuff that just happens. For example, if your house has been around a while, like this one, it probably has rusty pipes or older storage tanks, or it could have a septic tank. Stuff gets into our water from both natural processes and from our own activities. So, you think W.C. Fields had a point? Only at the top of his head. But by the time water gets to our homes and businesses, it's clean and safe. It has to be. Someone is watching. So, who's watching the store here? Well, see those letters? That alphabet soup represents agencies or regulations that were created just to protect us and the environment. One of their most important assignments is to make sure our water is safe and clean. So let's see. The EPA is the Environmental Protection Agency. SWDA is the Safe Water Drinking Act. And OGWDW is the Office of Groundwater and Drinking Water. Can't believe I remember all that, and I wasn't even a good speller. There are limits on the types and amounts of contaminants in our water. They make sure the levels of contaminants do not pose any health risks, and science has gotten so smart that we can detect some of the smallest particles in the tiniest amounts, like finding a specific grain of sand in Ray J Stadium. Pull out your readers. Anyway, our drinking water is constantly tested. If the water supply standards aren't met, the water can't be used. I guess you could call the EPA the water police. I wonder if they carry water pistols. Oh, well, just asking. But it's not just about the feds. Every day in your community, people go to the water department and work hard to ensure that the water you get is the best. And they do that no matter what was in the water when they got it. For something that just falls out of the sky, water sure is a lot of trouble. Folks use it, adding stuff that wasn't there to begin with. Then folks clean it. And other folks Check to make sure it's as clean as it needs to be. Everybody appreciates clean water, and by taking care of it for ourselves, we do better for everything else. What do you think, Bart? Let's go home. That's my boy.
So, Jorg, let me ask you this. Is it possible to clean up everything that's in our water, the pesticides, the nutrients, the oil that runs off from the autos, and all that stuff that we looked at in that video? Is it possible to clean that water once it's contaminated with all that stuff?
Well, with the technology we have today, absolutely. We can essentially clean or remove everything in the water down to the bare bone, which is H2O. But is that a healthy water you want to drink? Definitely not, actually. We have to put back in minerals to make it healthy and drinkable. So we can over-treat it, and we need to find the right level that we have a product that is fit for drinking.
That comparison to say that you could find a piece of pollution that's as small as a grain of sand inside the bowl of a football stadium is pretty amazing.
It is amazing. I mean, there are definitely some compounds that have some health concerns at very low concentrations, but we have analytical instrumentation today that we can look for the minute concentrations in the environment. And you find it even in very pristine settings. We have looked at mountain runoff in the Rocky Mountains. Even in snow melt, you find some of these constituents you wouldn't expect to find.
Well, let's get a question from one of our viewers right now. We have a question from a caller coming up right now.
My name is Alan Sharp, A-L-L-E-N-S-H-A-R-P-E, and I'm from Plant City, Florida. My question is it really safe to drink directly from the tap? Is it just a myth that bottled water is safer?
Andy, you want to take that one? Is it safe to drink from the tap? So many people are buying bottled water
absolutely.
right now.
Right. Yeah, absolutely. It's safe to drink from the tap. The EPA and the state regulators have done a great job protecting public health. It's a really interesting question because if you start looking at the bottled water, you find that a lot of times bottled water is actually tap water that's been through a machine where there's no treatment at all. Sometimes there's much higher levels of treatment than would be considered necessary. On top of that, you've got all the issues with the plastics, and some of these plastics actually leach things into the water. So, so absolutely, I'm a tap water guy.
So Andy, at home you drink tap water?
Oh yeah, I carry my little bottle around and fill it up everywhere I go.
So why do you think so much of the public, though, doesn't trust the water out of the tap? Why do you think that is?
I think that, now you're asking an engineer a public issue here, but I think it's really a perception that somehow if you're buying something out of a freezer at the store, it comes in a package, that somehow it is pure. Whereas, as I've said, I think our local utilities have done a fantastic job creating equal or higher quality water and a lot less expensive.
So. Bart, let me ask you, going back to that question, the grain of sand within Ray J Stadium. Is it necessary? Should we try to get everything out of our wastewater as we treat it and put it back into the system?
It's an interesting question because unlike other businesses who create a product for different consumers, we don't look at our consumers and say, this is what you need. The EPA says, this is what you'll treat your water to, and this is what everybody will have. As far as our discharges, as Jorg mentioned, to get down to the new levels, we will have to treat the water to the level he said, at 0.56 milligrams per liter nitrogen. It will be too pure to drink straight out of the system.
What do you mean too pure?
It'll be too pure, it'll be devoid of minerals that humans need to have in their water to consume it. And so we'll, as he mentioned, we'd have to put minerals back in to the water so it's safe for us.
You know, one of the things that I want to ask all three of you, one of the questions that's arisen recently is that we now detect levels of caffeine, we detect levels of pharmaceuticals in our streams and rivers, and even in some near oceans near the shore, near major cities. And I wonder, how important is it to rid our drinking water of all traces of pharmaceuticals or caffeine or some of these interesting substances that we're beginning to note that are in our water?